Okay, so we're going to look at a couple more examples of our elimination method. And so let's get started here. Consider the system 3x plus 4y equals 17, 7x minus 3y equals negative 22. As you examine your x's and y's here, you quickly realize there's nothing really nice to multiply if we look at the x's. To multiply the 3 by to get 7 or the 7 by to get 3. And likewise, if you look at the y's, there's nothing nice you could multiply either 4y by or 3y by to get the other number. So when this happens, we're going to have to multiply both equations. We have no way around it. So I'm going to say let's eliminate the x's. So when I look at 3x and 7x, I say, well, again, nothing nice to multiply 3 by to get 7 or 7 by to get 3, so I look for something they both go into. In other words, I say to myself, well, they both go into 21. So if I could make one of those a 21x and the other one a negative 21x, then they would cancel out. And so that's exactly what I do. So in the top equation, I'm going to say, let's multiply that by 7. I'm going to make the top one be a 21x. And the bottom equation, I say, let's multiply by negative 3, so that'll make it a negative 21x. Okay? So that's how we make that decision. Now which one I made positive and which one I made negative didn't really make a difference here. So we go ahead and do that, multiplying the top equation by 7 would give me 21x, 7 times 3, plus 28y, 7 times 4y, equals 119. Okay, that's 7 times 17. And then we multiply our second equation by negative 3. Get negative 21x, oops, went too far there, negative 21x, negative 3 times 7, plus 9y, negative 3y times a negative 3 will be plus 9y, equals 66, negative 22 times negative 3. And so our y variables are now opposites, so we can go ahead and add straight down. At this point, you may want to pause the video and try to solve the remaining equation yourself. So the x's cancel out, and we get 28y plus 9y equals 37y. 119 plus 66 equals 185. We said ourselves, oh no, this looks like it might be pretty bad. Until we try to divide both sides by 37, sorry. And when we divide both sides by 37, we find out, hey wait, 37 goes into 185 perfectly. Woo, we get lucky. Y equals 5. Once we know y is equal to 5, we can pick either one of our equations there that we started with, plug 5 in for y. I'm going to pick the 3x plus 4y equals 17. And I'm going to go in now and replace y with 5. When I replace y with 5, that'll be 4 times 5. So I'll get 3x plus 20 equals 17. And this time I now want to solve for x. 3x plus 20 equals 17. So I subtract 20 from both sides, get 3x equals negative 3. Finally, I can divide both sides by 3 and get x equals negative 1. So I get the solution negative 1, comma 5. Okay? Let's move on to another example. Here we have the equation 2x plus 5y equals 12. 6x minus 3y equals 4. Once again here we want to choose a variable to eliminate. This time I say to myself, well wait a minute, look at those x's. One's a 2x and the other's a 6x. So I can turn that 2x into a 6x. Now I need them to be opposites so that they'll cancel out, so I can get by with just multiplying the top equation by a negative 3. And so I go ahead and do just that. So multiply through by a negative 3. I get negative 6x minus 15y equals negative 36, and then the other equation is still just 6x minus 3y equals 4. Okay, we add down, the x's cancel out. Get negative 15y and negative 3y would be negative 18y equals negative 36 plus 4 would be negative 32. Divide both sides by negative 18 and simplify. We get y equals 16 over 9. So this time we got a fractional answer for y, 16 over 9. Now we could take that 16 over 9 and we could plug that into one of our equations. And you kind of saw an example of this in one of the substitution videos. It is a bit of a pain when you have to take a fractional answer and plug it in. So what I'm going to do instead is I have another option. And that is I can go back to my system and I can say, let's eliminate the other variable. So I can actually go back and redo elimination again. This time eliminate the y's. Okay? Instead of taking and having to evaluate the equation with a fraction and have to solve that, I can actually go back and just do elimination again. So to do that now, I'd have to eliminate the y's. To accomplish that, I would say, well, let's multiply my top equation by 3 and my bottom equation by 5. That way I can make the top one be a 15y and the bottom one be a negative 15y. Okay, and so we proceed and do just that. The top equation multiplying by 3 would be 6x plus 15y equals 36. The bottom equation multiplying by 5 would be 30x minus 15y equals 20. And then we can add down, the y's will cancel out. We get 36x equals 56. We can then divide both sides by 36. And simplify, we get x equals 14 over 9 when you do your reducing. And so this is another option. You can actually use this every time if you want to. It's particularly helpful when you get fractional answers. And that is to use the elimination method a second time, or as I like to call it, because it sounds kind of cool to me, we use double elimination. Okay, one last example. Consider the system 3x minus 2y equals 3, 9x minus 6y equals 2. Again, we want to solve this system by elimination. So we choose a variable. I say, hey, look, I got a 3x and a 9. So I could just multiply the top equation by negative 3, and the x's will be opposites and they'll cancel out. So I do that. Multiplying the top equation by minus 3, I get minus 9x plus 6y equals negative 9. Leaving the bottom equation alone, I have 9x minus 6y equals 2. Notice when I solve this system, both the x's and the y's cancel out. So they're gone. And I get negative 9 plus 2 is negative 7. I have an equation, 0 equals negative 7. And if you remember what we talked about with substitution, the same idea applies now. This is an inconsistent system. It has no solution. Okay, so hopefully that'll help you out as you're doing elimination. Until next time.